Let's look at the final two parts of the application. For one, we want to be able to create web pages based on Markdown. And second, we want to be able to store our content as a JSON document so it becomes a worldwide citizen in the world of the internet so that our data can be used from anywhere and from any device. I don't want to give an introduction of Markdown, but Markdown has become more or less the new language for writing documentation in a non-proprietary manner, and it also has become the basis for a lot of content on the web. Something that wiki content has been known for previously, but now I gotta admit, I never learned wiki, how to write a wiki and all that special markup language in a way. Instead, I got involved with Markdown pretty quickly because Markdown also has the ability to designate source code, and then with plugins, which are mostly found in the Python world, for example, or PHP world, you can even get code highlighting and other stuff to make your documents look great on the internet. In my case, in case you're interested, my web page uses a tool that is called mkdocs, which is originally designed for technical documentations, and that's exactly why I use it, because I think as a developer, the best thing that you can have is an engine that has been designed for technical documentation. So if you look at my tutorials, I'm able to embed video content, but I'm also able to have textual content as well as like nice boxes here, and also source code is also nicely highlighted, be it HTML, JSON, or even Delphi. So that's the number one reason why I opted to go with a technical system like this, which also lets me build tags. And these things then come from Material mkdocs, which is an add-on, so to speak, for these kind of documents, and that's how I generate all my web pages. And also content I want to share with customers if they want some sort of documentation. You can build a website or a web server. You can build a website or a web server that hosts your documentation content very, very quickly. So Markdown has really become my format for generating web content, unless, of course, I write a web application which puts everything into a completely different context. For static web content, I usually use Markdown. With that being said, it's pretty easy to convert our stuff into Markdown, to be honest with you, because if we look at an example, let's look at the first book. What I do is I add the file header, which is usually 3 dashes, and then I add tags Delphi. I might extend this example at some point to support more than one tag. And then the header is the book title, and then the subtitle is just in italic font. The subtitle then is just in italic font, which you do with an asterisk. And then bold is 2 asterisks, which is my text already. So this is here. This is the Markdown that I copy-pasted into the description field. So this is the description field, and then I generate learn more, and this table here is generated, and it's just a bunch of URLs and flags that is being generated based on the stores and on the editions that are available. So you can see here the editions are on the x-axis of the table. So we have the store, and then we have edition 1, edition 2, we have a separator, then we have the first store, we have the URL, the flag, and then the URL for the first edition, the URL for the second record in edition, and that's how we loop everything. And that's literally the loop. The only difficulty is that you need the names of the editions first for the title, and then you always have to iterate to get the URLs for the store according to the store that is being used. So first we iterate both editions, Then we iterate all the stores and look up if the edition is available in the store. With that being said, I added it all to the DB manager. You could create your own Markdown class and pass the queries and everything over there. For simplicity, I just said, okay, save to Markdown. We needed a folder, not a file, because we create multiple files, one for each book. And we also create one cover for each book. It's also something. We also don't create some sort of index or anything. It is just one file per book. With that being said, I have two different column types. This is specific for the Markdown interpreter that I use. My Markdown interpreter allows, with some certain Python extensions, allows me to center my table content and left align my table content, which is signified here with the colon on the left and colon on the left and right for center. And then I also have a cover width, how wide my cover images should be. So I created a constant for that. And then I needed L lines, which are the lines of my file. That's it. So I don't use like any streams or anything. I just use a simple string list, which will be designed as the lines inside of my file. And back in the day, I still have that in there. I had an index file, which I created here. So L index. I wonder why this isn't being picked up by the compiler, to be honest. I'm quite sure it will be. If I looked into the hints, I've just been too lazy to notice it now. But I doubt that L index is still needed. See, I can remove this line. This is in there from a previous incarnation of the code. So as I said, we go to the query books and we add the header, and there we see how great it is that we have Delphi 12. I can do these things now very, very easily with multi-line strings. Just add the string in here between 3 quotation signs. That's a multi-line string. And then I have a counter in here. So I have like book 1, book 2, book 3. That's all I do. I don't want to tie it to the IDs of the books inside of the database, because I honestly I use the books query, which is ordered by publication date. So the book that has been published last is also going to be first on my web page. So if we go to Holger's code, if we go to books, this is the one that has been most recently published, and it's book 1. And if I go to book 2, that's book 2. Most recent published, but the one before the most recent. And that's the order that I want. So this is the counter for that. And I clear all the lines because I'm starting a new file. And then I add the header, and I noticed that back again, previous incarnation, I had the header with parameters and the format string. That's all no longer there. So we add the header, that's this, as a starting point. And then I add the title of the book. And if the book has a subtitle, I add that too in the next line with an asterisk in the front, meaning it's going to be written in italic. I add an empty line. I add the book description, another empty line. I add a headline for learn more. And this is where it gets interesting, because the image file, in this case, I use the ID of the book. So this is cover. For the first book, you see that if you look at the numbers, that these numbers here do not match 1, 2, 3, 4, 5. These are actually the IDs of the book. I could have adjusted that as well, but this way, it's really associated with the book inside of the database. So, and then we have, as the second parameter, we have the width. So I could generate multiple images with multiple widths if I wanted to. I create the image path with the folder that's been passed in. Remember, we get a folder, and that is then going to be combined with the image file name. And then I'm going to use imaging. I don't have any difficulty reading any file format and writing any file format. That's the bliss that you get with this framework. So I create a new bitmap, but one that is from the imaging library, not one that is from the VCL TD bitmap. So this is more like a VCL picture, so to speak, but I read it from the field. This is a field, right? This book's cover here, that's the blob field. I don't know if the IDE shows this. See, this is the blob field. So you can literally say, read from the blob field cover the information, because this is a DB bitmap. But don't put too much focus on bitmap, because in imaging, everything that is an image is called a bitmap. So now I have my bitmap interpreted, whatever, in a cover, and then I can call the resample function, which allows me to say, hey, this is supposed to be 250 pixels wide, and the height, please calculate it for aspect ratio. So I don't know how high it's going to be. I don't care. I just want to make sure it's 250 pixels wide. The framework does the rest to keep it proportional. This will not make it a square, for example, 250 by 250. No, this will calculate the height automatically, and you do this by setting the parameter to -1. And then you have different resample filters. This particular one, I will not even try to pronounce it. This particular one has a very good quality if you make big images smaller, and it uses like very, very advanced algorithms. Don't even try to compare it with tbitmap.resize. It's going to yield results that are significantly better. I think the documentation from Imagine has examples. So I'm looking at the examples here. I just wanted to show you real quick. So we have, these are all the different filters, as they are called here, that are available. And there is a comparison available if you look at the T-resample filter. Here it is. So here are the different filters. And here we see, like on the left, we see what happens with the filter if we upscale a small image by 300%, and what happens if we downscale a big image by 20%. You see, if we use the standard routines that are included with Delphi, it doesn't look very good. But for example, RF triangle yields good results if you make the picture smaller, but horrible results if you make it bigger. And here you can see there's even algorithms that reach a pretty good quality, especially the one that I use, is even good for making small images bigger, but it leads to a very, very clear picture to compare to this one when you make it smaller. So that's the reason why I picked this. Of course, if you iterate this and do it for thousands of images, you have to put the time into consideration, how long these algorithms need, and they have different speed, as you can see here in the table. For example, the fast linear is truly one of the ones that are fast, but the fastest one of all of them, of course, is here the WIC linear, which is part of Delphi, but I'm quite sure it will only be available on Windows, obviously. And if we look at this, what the quality looks like, so you see that it's not nearly as good as, for example, bicubic or the one that I used here. Okay, so there's truly, you have to balance time and quality for your particular use case. In this case, it doesn't matter if it needs, what do we have here? 2 seconds or 0.2 seconds, or if it needs 0.004 seconds or whatever. It doesn't really matter to me. So that's why I picked the good quality, high quality, processor intensive filter, that produces sharp images. That was the key for me. Time was not a problem here. So that's the resample. And then we create a file stream and write the output as PNG. The nice thing is with imaging, again, you can do IO, and then you have all the different image formats here that are available. for example, if you need layered images, which is a great tool to have, you can do Photoshop, which is layers, and Imaging itself also has their own image format if you have layered images and stuff. So definitely worth your look. So we have l.io PNG, we have a PNG file, and we do that for every cover image. And of course, we want to reference that cover image, so we use the markup language, which is exclamation mark, square brackets. I'm not doing a good job here. This should be a better annotation, what the image actually is. I say it's a cover image. And then in round braces, you say the file name, and then basically the alignment that is something specific for the markup language that I use here, the Markdown language that I use here, which allows me to align left, center, right. That's something that is not available in every interpreter of Markdown. And now we can start building the table. Let me add that as a comment here. So we have the buffer variable for the first line. So we have store, and then I create the first column, and then the separator. And then this is basically the separator line for store. If I look at the result, so let me open the Markdown at the same time. So we're at this position right now. So we have the store. Maybe I can even align this next to each other. That works. Should work. So here we have the store. Make it a little bit smaller. We don't need it that wide. Yeah, perfect. So we have the store on the left, and then the black and white edition would be the next edition, but I'll do two lines at the same time. So I do the store and I do the separator. So that would be this left align separator, L sep left, that would be that. And then each of the editions, the flags are center lines. So now we do these, and one for each edition, and the edition itself also has to go on top. So to L buffer, so to the top, I add the buffer that I had before, and then I add the name of the edition, which is black and white and color 2 times, and then here the separator 2 times center. And I do that for each record in the edition. So at that point, I have this created. Then we add, basically in the file itself, I add a line between the cover image here, and then I add the buffer, which is this first line here, and then I add the separator, which is this line. And now we iterate all the stores and create each of these lines. So the first is the name of the store. So at this point we have this, and then we look up if the store has this edition, because now we iterate all the editions, and we do that each time for each store. We iterate all the editions, right? Because we have all the editions on the columns in the table. It's always the same 2 editions, but we evaluate them for different stores. We also need to read unavailable stores, the query. And the thing is that query all editions is linked to unavailable stores, but not query editions. Let me show you that in the data module. It might be confusing if you read this code, but it all makes sense. So all editions is linked to unavailable stores, because what we do here is that we say if we navigate all editions, that's the master table for unavailable stores, only on available stores are being shown, right? So only the unavailable stores of the edition that I'm navigating in here. So we have yet again another master detail relationship here. So this ID is the ID of all editions. And we don't have that if we navigate query edition. Okay, that's a little bit, we want to iterate all the editions, and we don't use the table all editions that shows like all editions with a book table, and that table would also list all the other books. We want to only iterate all the editions of the book that we are looking at right now, but we still want to know which are the unavailable ones. So you have two options. You either create a new query that you link to query editions. That would have been a totally viable solution. Or I simply jump and query all editions to the right record that matches the one in query editions, and then read query unavailable stores. And that's what I do in the code here. I simply locate the record and then determine the state if the book is available or not, or I shouldn't say book, if the edition is available in that store. And if it is available, meaning it is not unavailable, then I add the markup for the flag, which is this is nomenclature that is there. You can do flag underscore and then the ISO code, and then you get the flag in Markdown. And then here, the link, which is basically built out of the country code for the store, the domain of the store, and then the serial number for the book is followed here at the end, which will lead, for example, for the US store, flag underscore US, as you can see it right here, and then amazon.com/DP, and then this is the link for that book. And then the next edition, if you don't have, if it's not available here, we simply don't add a link, but we just add the, right, so let's assume it wouldn't be available in the US, this would be missing. That's the only difference. And with that, we're ready to go to the next edition. So we have this, and then we do this with basically this part here. So the only difficulty here is that it's two loops that are embedded in each other. So we have one loop that iterates all the stores and one loop that iterates all the editions, with the added difficulty that we have to find the record in another table so that we get the master detail relationship for the unavailable stores. You can evaluate yourself if you rather have another query that you don't have to reuse the query that you already have, or build or query even here instead of using a query that we have on the data module. That is also something that you could do. All approaches will lead to the same result in a way, so I wouldn't even think about it twice, which one is better. With that, we add this line that we just created here in the buffer to the file, and then the next store, another line, and then the last thing is to create the file. We increase the counter, so we have it on 0 in the first iteration, so it goes now up to 1, and that will then create the file name with the folder that we handed in, and then format book, in this case 1.md, and then we can simply say lines save to file or book file, and then we iterate the next book. And this is how we can get all Markdown files generated. The complicated part is really assembling or composing all the strings, to be honest with you. It's not the difficulty is not the database technology that we use here. However, the result is pretty amazing, in my opinion, that you get a web page where you have, if you look at the book, this is the format that you get with these few lines of code, if you think about it, with a nice image here, and then with all the flags, with the hovering links and everything. And then for the different editions, here, these two are missing. And these flags, they're all part of the template that we use, so to speak. It's literally something that is part of the web publishing that I use, that I have all these flags available, for example.